Hello and welcome to part 2 of quality control in biochemistry for semi-auto analyzers and then fully automatic biochemistry analyzers. Okay, so in part 1 we talked about what QC is, and we said that it was simply a test to actually assess the analytical phase of your biochemistry machine to ensure that the results that will be generated from it is correct. In part 2, we want to talk about quality control samples. I mentioned that we have two main types. We have the commercially available ones, so they come in a vial that is lyophilized, and then you have to reconstitute, then you aliquot them, and then you freeze them at minus 10 degrees. When you need them, you thaw them and then you use them. They also come with their expected values and then their standard deviation. But in this case, we're going to talk about the lab made ones. And when I say the lab made ones, I simply mean patient sample that you want to use as your quality control sample. When that happens, then it means that you have to assay it about 20 times, at least 20 times, to get your mean and then your standard deviation. Then from there you can now begin to use it as your quality control sample, and that is exactly what we are going to do in this part 2. Okay, so I'm going to use choose albumin as my test parameter in this video. It's a simple endpoint method, and then it's BCG reacting with the sample to produce a colored complex, and the intensity is equal to the concentration of the albumin in the sample. So I have this patient sample that I'm going to use as my quality control sample. Okay, so I'm going to assay it 20 times. That is the requirement. The least amount of times that you need to do this is 20. Okay, so let me increase this for you. So I'm going to aspirate my DI water. I've already done a video on how to measure albumin, so in case I'm moving too fast, you can go back and watch that one. Okay, so the water has aspirated, the graph is okay, and I'm going to go through all 20 of them just to explain a few things concerning precision and then accuracy to you. So as we measure them, I'm going to talk about systematic error, random error, trends, and then shifts. So this is my preparation. I have it here. I'm going to measure it. Okay, and now first the graph is okay, it's moving fine. As I already said, you always have to study the graph to see. So our first value x1 is 4.8. So our first value is 4.8. That's our first measurement. Then we go to our second measurement. So I'm not going to wash, I'm not going to do it. I'm going to measure it again for the second time, and let's see what we get. So this is our second measurement without washing or doing any other thing. Let's see our second value. Our graph is quite okay. That went up to 5.0. That's the second. You see that the difference between the two is quite huge. Okay, I'm going to measure it for a third time without washing, and I'm emphasizing that to show you something. So I want you to observe something. So it moved from 4.8, and then the second reading was 5.0, then it went to 5.1, but my sample is finished, so I'll make another preparation, and this time I'm going to wash and then reset it all over again. So albumin, and then aspirate my water. So let me just quickly explain this to you here. Our first measurement was 4.8, second one 5.0, and then third one 5.1. You realize that it is increasing with each measurement that we do. That is what we call a trend. So that is what we call a trend. It's a precision problem. So a trend by definition then is a gradual but steady change in QC results moving up or down away from the mean. So it's gradually moving. It's gradually moving away. That's a trend. It's a problem. It's a minor problem that you have to deal with, and you realize that that is happening because I'm not washing. I'm just measuring one after the other without actually washing. And so in my fourth measurement, I actually washed and returned back. So let's see what results we are going to get. So basically that is what we call a trend. If you are doing chemistry, you should be watching out for that. So I measured my fourth measurement for now. So that's my fourth measurement, and let's see the results we get. So we go back to 4.4. So we have 4.8, and then fourth measurement, when we've done some washing, we had 4.4. Let's do number 5 and see. But this time we are going to wash and then see. Let me return and then let's aspirate another. So these are all things that you should be mindful of. Trends, shifts, and we're going to talk about all of them as we go on. And these are things that are very technical, and the more you go on, the more you gain experience, the more you're able to work out and produce quality and reproducible results with your machine. So we're going to measure our fifth one. Okay, so that is 4.4. So you realize that when we wash each time, we get more higher precision, as you can see. And so from this demonstration, you realize that it's good to wash after each measurement. I mean, it's the best way, practically demonstrated.